So I'm going to do a video of how to score the VMI using a protractor. So on this first form, which is the same scoring as this one, it says it has to be within 30 degrees of vertical. Usually on this one I can just tell by looking at it, but you would line up this line on your protractor, measure the angle of the line. It's 92 degrees, so it can be within 30 degrees, so it's a pretty wide range. That's why I don't usually measure that one. Same thing with the next one, 30 degrees of horizontal. So I put the protractor this way, or you can do it this way. Horizontal would be 180, so that one again is fine. The circle doesn't have an angle, but I just do that one by hand. The cross, each leg needs to be within 20 degrees of the correct angle. So on this type of one, you can extend out the lines ever so slightly to the edges, and then I always line up my dot, my protractor, with the line of the test, and then I measure using that line I extended out. So this one was like 16 degrees. So that's within 20 degrees of horizontal. And then same thing with vertical. You can extend it out to the box, and then putting it on there, it's within 20 degrees of horizontal. So this sort of continues. I usually extend it out to the box, or I kind of just estimate it being extended. So extend it to the box lightly. Try to do it in a different, so it doesn't look like the student did that, but this one needs to be within 110 to 160. So putting my point there, it's between 110 and 160. So this one's 138, so it's good. The square doesn't have any angles. Let's see. This oblique line needs to be 20 to 70 degrees. So again, I can just tell the student just got it because it looks exactly like the one above, but if you wanted to test it, 20 to 70 degrees. The oblique cross needs to be between 20 and 70 degrees and 110 and 160. So again, sometimes as a kind of a cheat, so I don't have to extend every line, I'll use on my protractor these vertical lines. If I line those up perfectly with the edge of the box, it's kind of a cheater way to do it, and then it's 48 degrees. So that's within the 20 to 70. This one needs to be 110 to 160. So as long as it's exactly parallel with the bottom line, or if I use the tick marks to line it up perfectly, then I can guess. So I'll always extend it out if it's close to being wrong, but I can just tell that one's gonna score based on just looking fine. For the triangle, it doesn't have to have any certain angles. This one confused me for a while, so I always use the measurement on my protractor. These are 1/16 inch to see how big the overlap or anything is. This one's fine. No major distortions. Height within a 2-to-1 ratio. So I like centimeters because they're just way easier to add math-wise. So this one is 4 centimeters. This one is 29 millimeters. So it's within 2-to-1 ratio. I would be looking for less than 20. And then the bisector of the circle passes through the corner of the square. So basically wherever the square is touching the circle, you cut the circle in half, you bisect it. So if it's touching right there, this approximately cuts the circle in half, so it's two halves. But then that line has to project into the square. That's one of the requirements. So wherever it touches, cut the circle in half, project the line in. So this one was a scoring form. So on this one, I always measure that intersection gap. Let me get the camera. Using 1/16 of an inch. I don't like my first one because it's kind of rounded, so I kind of look at another one. That one was just barely fine. Oh, it's 1/8 of an inch, sorry. So no, that's fine. Over half of the horizontal is within 15 degrees of correct. So again, you can kind of extend out the line. And then if it's, when I put it on the point there, it's coming out at about 8 or 9 degrees, so it's less than 15, or it's fine. And then both of the diagonals are over 10 degrees from vertical. So again, looking at this, when you're extending it out, it can't be 80 to 90 or 90 to 100. It can't be right up there on vertical. So this student was fine, 120 on this side and 150 or 30 on that side. So it's totally fine. They just don't want it vertical, like straight up and down. On this one, you have to have all of the criteria from Form 10, which was just the cross before. So again, 20 degrees of the correct angle. This student is fine just estimating. It was like not a problem. But with that one being said, he doesn't have the, a lot of times I'll just, before I even measure this one, I'll just disqualify based on the floating tips and the sharp points on the tips. He has that, but because of the way he made this one, it was just automatically disqualified. But you can always measure that. There's no other protractor use on this one. He got this one. The first one I always do is the 7. 1, 2, 3, 4, 5, 6, 7 openings. If they don't have that, just then don't bother. I don't usually have to measure this one. It just says one circle clearly below the others. But if you wanted to, you could put center dots in all of these and then be sure that the lowest side of the triangle must be 20 degrees or more off of the horizontal. So you can correct it. I don't even know how you would do that. To form a triangle, the lowest side of the triangle must be 20% more. So this student's, it's not even really a good example of how to do it. But you make a triangle, and whichever side's the lowest, I guess this one has to be more than 20 degrees. It's like 70, so 60 or 70, so it's a lot. But it's one way to check it. This one I measure almost every time. So I put them center dots to start on the corners, and then I draw a line on that one, and then I measure it off of using the box like I've been doing, and then it's 10 degrees. Oh yeah, this student, I was like, it's so close. It's 10 degrees, and if it's 10 degrees off, you can't give it to him, but I gave it to him because it's right there. It's so close. Him or her. And the other one on this one is when you connect all of these, the center circle has to be touching, at least touching the middle dot. So like this one, you connect the two centers, that middle dot's not touching, but it only has to be on two sides. The baseline and one other side has to be straight. And then the dots on the same side have to be within a 2 to 1. So again, I use millimeters for this because it's easier for me. This one's 1 centimeter. This one's 8 millimeters. This one is kind of confusing. 1 and again 7 or 6. So all of the sides are within 2 to 1 ratio. You'd be looking for like 1 centimeter, 2 centimeters, or 1 centimeter, half a centimeter. So that wasn't a problem on this one. And then this one's automatically disqualifying because it's not even touching. But the one thing on this one is that this diamond or sideways square this has to be within 10 degrees. So again, you can extend it out. Line it up. His is actually 12 degrees, so it would have been disqualifying for more than one reason. Again, the 16th inch gap. And then the height of the square has to be touching 1/3 the height of the circle. So I can't show you on his, but on this one, I like to measure in millimeters how big it is. So this is 2.5 centimeters or 25. And then I divide that by 3. So 25 divided by 3 is approximately 8. So I'll draw a little line to 8, draw a little line 8 up from 25, 8 millimeters. So that's the middle third based on just kind of quick math. It is touching the middle third. If this was the students, obviously it'd be fine. But just to show you how to do that middle third, because that's kind of confusing. And then the height ratio has to be 2 to 1. So again, this is 23 millimeters. This is 25, so it's fine. My students probably would have been okay on that too. 30 and approximately 34. So, okay, this is where we start falling apart. So once you get 3 X's in a row, I always put an X if it's wrong. Once you get 3 X's in a row, then you fall off and you just stop grading it. But for the sake of this video, so on this one, 4 good corners. So these are good corners. This one's not so good. Openings less than a 1/16 of an inch. Horizontal within 170 to 190. I think you're catching on. I extend the line. I use the protractor on the box. And then, so this one is not, it says 170 to 190. And my protractor only goes to 180, so I had to turn it upside down so you could see it. But that's way past 170. It's 162. Okay, a dog ear, so that's kind of this. Shortest side, at least 2/3 of longest side. I had a kid disqualify on this the other day, and it was so hard the math to figure it out. So this one's like 43 millimeters, and his shortest side is 31. So you have to literally get a calculator out and do 43 times 2 divided by 3 and see if that's more or less than 33. It's just crazy. 2/3 is a really weird thing to ask for. But this one he clearly didn't get, but I'll show you because it's a hard one to measure. So it has to have 2 triangles. The 2 corners of the inner triangle clearly touch the middle 1/3 of the outer triangle. So again, on this type of thing, I would measure it. So 45, divide it by 3, so 15, and then every 15 I would mark. So that's dividing it into thirds. So this one's 40 divided by 3 is approximately, what, like 13? I'm just doing this on the fly, guys. So that's the middle third and the middle third. So 60 millimeters divided by 3 is 20. I love when it works out like that. So cleanly touching the middle third is when there's less than 1/16 inch overlap on the last side, and the other two have to be perfectly touching. The outer left angle within 60 to 120. So of the outer triangle, the left angle, so that's this guy, needs to be 60 to 120. So you can just put your protractor on there like usual. If it doesn't quite reach, you can always extend out so that you have a nice accurate measurement. So this would be 90. It's a right triangle. So my student, oh, it didn't quite make it. It's 53. So didn't quite get to the 60. It wasn't gonna work anyway, but and then the outer triangle right side slopes 100 or more. So this is the outer triangle's right side right there. Sloping 100 degrees or more means past 100 here. So 110, 120, anything past there. So the sample's 110. I'm just showing you on the sample because mine is so bad. So that's how you measure for that one though. On this one, no criteria for the protractor really, but you do kind of have to use your straight edge. If 3 dots fall in a line, so you kind of can draw these little lines and just see. Actually, the student might have got a score for this one. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, he had 9 dots. So, but he had the circularity piece that they're looking for, where the middle dot between any 2 dots does not touch the line. That's kind of how they grade that one. And then also, the greatest space between any 2 dots is more than twice the shortest space. So like this would be one of his longest spaces. It's approximately 12, so it can't be twice that. So the shortest one, maybe this guy, is only like 4. So that would be another disqualifying factor, is that this is too close comparatively. It has to be evenly spaced. Can't be twice as much. Now we're getting into the nitty-gritty ones. He tried his best. So all sides indicated. So I usually like kind of, this one's hard to grade really, but you kind of just like follow it with your eyes and be like, yep, 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 yep. This one has all sides indicated. This one doesn't, I don't think. I mean, this one, this one, this one, this one, this one. He tried so hard. And then the most obtuse angle, which is always this guy. No, this guy. Oh my goodness. Can be kind of missing. I mean, not missing, but it says that can be rounded. So they can kind of round that one. But and then they have to overlap, but not extreme. On this one, I like to look at the manual and look at the ones that qualified for the overlap, because as the score, because it kind of helps you decide. Let's see, I didn't even score this one for the student because we had already fallen off the map here, but let's see if he got it. 4 good corners, so sort of. No openings, but this is kind of an overlap. But one of the sample ones has an overlap, so that would probably be okay. Both acute angles are 60 degrees or less. That's where I think he's going to fall off, because this looks like a square. So it kind of extending that out. Maybe I should actually extend it out. It's kind of hard because it's like, it's not really a straight line, but I just kind of go with the average. It's not exact science. So 58, so not 60 degrees. 60 degrees or less. So that one would be okay because it's so narrow there, but I'm guessing this one's not going to be. Let me extend it out so I can measure it properly. And then right there, 80 degrees. So that one's too large, not acute enough, too obtuse. And then the horizontal axis within 170 to 190. He was pretty close at getting this one, but get disqualified. Because that's a pretty good axis. It's 1 degree off. It's not bad. Shortest side 2/3 of the longest side. So again, that weird math, 30 millimeters to 25. You would have to put that in. 30 times 2 divided by 3, 20. So you'd be fine. But it's still disqualified based on that angle. This one's not bad. Let's see. 3 complete double circles. All circles overlap. So kind of the same criteria as the other one of the 7 openings, sort of. And at least 1 clean 3D overlap. So he would have had to be thoughtful and like stopped and started, but he just went straight over. That's pretty typical. Doesn't get the score. Last page. Thanks for bearing with me. This is a long video. Okay. On the box, usually it's pretty clear if somebody got it because it's just the correct number of parts, the correct orientation, and no evidence of confusion, so it should look almost exactly like the picture. This one would not count. I feel like that one's a learned one because a lot of kids know how to draw a 3D box, and then they just do it or they don't. This one has to be a parallelogram. Can't be a square. The inner one has to be a horizontal rectangle, so that's more of a square. And then it needs to be shifted right and down as evidenced by the lower right diagonal line being the shortest. So you can measure them. His is actually shifted right and down. It's not super bad. No evidence of confusion or distortion. So, not bad. I would probably actually give him mostly the credit. This is a huge overlap, but it doesn't say you can't, so. This one. Okay. All corners of the triangles extend beyond the opposing sides. 1 overlapping and 1 underlapping on the same triangle. So again, having notice the detail of underlap and overlap, and no extreme distortion. So if you have any questions, feel free to comment and let me know how it goes. Thanks. Bye.